Hello again. So let's examine this problem. Triangle XYZ is equilateral with a side length of 10. A circle is constructed with center X and radius 10, thus passing through Y and Z. Find the area of the sector YXZ of the circle. In other words, find this shaded portion bounded by the radii XY and XZ and the arc YZ. So, something we can note is that the radius is 10 and that this triangle is equilateral. Now, if we're finding the area of this shaded portion, well, we know how to find the area of the entire circle, and we have enough information for that, so let's start by finding the area of the whole circle. That's pi r squared, where our radius is 10. So, simplifying that, it becomes 100 pi. Now, we need to shorten it up by finding just the area of the sector. Well, it's bounded by this arc YZ, and when we did arcs yesterday, that made us think of proportions or ratios. What ratio does the arc take up of the entire circle? Since this triangle is equilateral, that means this angle is 60 degrees, which means that the measure of the arc YZ is 60 degrees. Okay, now we could find what ratio that this arc takes up of the entire circle by doing 60 degrees over the entire circle's 360. And we can simplify that to 1 over 6. So this arc is taking up 1/6 of the circle, which would also imply that this entire region is 1/6 of the circle as well, since this region is bounded by the arc. So to find the area of the sector, we're going to take the area of the entire circle, 100 pi, and multiply that by 1 over 6. Well, 100 divided by 6, they're both divisible by 2. So 100 divided by 2 is 50, and 6 divided by 2 is 3, and keep our pi. So the area that we want is 50 over 3 pi. And this leads us to our development of the formula for the area of the sector. So in our last problem, we found the area of the sector by determining the proportion, which would be this section right here. So this is our ratio. This is the ratio of the sector to the entire circle. And this is the area, pi r squared, of the entire circle. So it's such an easy formula that you don't even really need to remember it, because if you understand how it worked when we did the problem, there's no need to memorize it. But if you need a formula to memorize, here it is. It's the ratio of the angle AOB over 360 times the area of the entire circle.